Welcome to G Fun Facts Online. Today, we're talking about a sea that died. Not just dried up a little, but vanished completely, leaving behind a 2,000-kilometer-long salt desert hotter than Death Valley. And then, in a flood of truly biblical proportions, it came roaring back to life. This isn't a sci-fi plot. It's the real, violent, and incredible history of the Red Sea. The story starts about 30 million years ago. Africa and the Arabian Peninsula weren't separate landmasses. They were one solid block. But deep beneath them, in the Earth's mantle, a giant plume of superheated rock was pushing upwards. Think of it like a massive blister forming under the planet's skin. The pressure caused the crust to stretch, thin, and finally, crack. This process, which geologists call continental rifting, is the same force that's tearing East Africa apart today along the Great Rift Valley. It's the birth pangs of a new ocean. The first signs weren't a sea, but a series of long valleys and lakes. And it was a violent birth. Massive volcanic eruptions flooded the region with lava, in some places piling it 2,000 meters thick. These flood basalts are the geological scars of that fiery beginning. It wasn't until around 23 million years ago that seawater finally arrived. The Mediterranean Sea, which was at a higher level back then, broke through the northern land barriers and poured into the deepening rift, turning the chain of lakes into a long, narrow gulf. This was the first draft of the Red Sea, and it was teeming with life. We know this because we find fossilized coral reefs from this period along the coast of modern-day Saudi Arabia. The engine driving this whole process is called the Red Sea Rift. It's a divergent plate boundary, which is just a fancy way of saying it's a seam where two tectonic plates, the African and Arabian plates, are pulling away from each other. They're moving apart at about 1 to 2 centimeters a year, roughly the speed your fingernails grow. It sounds slow, but over millions of years, it's more than enough to create an ocean. In fact, in 2005, after just 3 weeks of intense tectonic activity, the sea widened by a staggering 8 meters. It's a powerful reminder that our planet is constantly in motion. Today, the Red Sea is what geologists call a juvenile ocean. In its central, deepest part, new oceanic crust is being formed right now. This area acts like a mini mid-ocean ridge, with active volcanoes and hydrothermal vents gushing out superheated, mineral-rich water. These vents and the super-hot, salty brines found there were some of the first clues that the Red Sea was actively growing. So we have a sea that's destined to become a great ocean. But before it could reach that future, it had to face complete and total annihilation. Around 6.2 million years ago, a perfect storm of geological events conspired to erase the Red Sea from the map. The main problem was its plumbing. The shallow connection to the Mediterranean Sea in the north got blocked. This was due to a combination of global sea levels falling and the land itself being pushed upwards by tectonic forces. The northern tap was turned off. Meanwhile, in the south, a huge natural dam of volcanic rock, called the Hainish Sill, prevented any water from flowing in from the Indian Ocean. So the Red Sea was trapped. It became a giant, enclosed bathtub under the scorching desert sun. In this incredibly arid climate, the rate of evaporation was far higher than any water coming in from rainfall or the few rivers that fed it. The sea began to shrink. As the water evaporated, the salt was left behind, making the remaining water saltier and saltier. This salinity crisis killed everything. The thriving marine ecosystem was wiped out. As the last of the water vanished, it left behind unimaginably thick layers of salt and gypsum. In some places, these salt deposits are 2 kilometers thick, 2 kilometers of solid salt. For about 100,000 years, the Red Sea was not a sea. It was a sterile, hyper-arid salt desert, a geological death valley stretching over 2,000 kilometers, baked by the relentless sun. Now, how do we know this? This isn't just a wild theory. Scientists, particularly from King Abdullah University of Science and Technology, or KAUST, have pieced this story together like geological detectives. They use seismic imaging, which is like giving the Earth an ultrasound, to see the layers beneath the current seafloor. These images show a clear boundary, a line where older, tilted rock layers are suddenly covered by a new, flat layer. That boundary is the old, eroded desert floor. They also drill deep into the seafloor to pull out sediment cores. By analyzing the tiny microfossils in these cores, they can tell what the environment was like. They see a point where all the marine fossils disappear, and all you find is salt. Then, they use geochemistry to date these layers with incredible precision. By tracking changes in elements like strontium, which changes at a known rate in the world's oceans, they can put an exact date on when the sea disappeared and when it came back. It's an incredible story of planetary forensics, revealing a 100,000-year-long chapter when one of the world's most important waterways simply wasn't there. The empty, salt-encrusted chasm that was the former Red Sea was not destined to remain a desert forever. Its return was as sudden and violent as its disappearance was slow and creeping. The very geological barrier that had doomed it, the Hainish Sill in the south, became the agent of its rebirth. Around 6.2 million years ago, that volcanic rock dam finally broke. Seawater from the Indian Ocean, which was at a much higher level than the desiccated basin floor, began to surge north. This wasn't a gentle trickle. It was a catastrophic flood of unimaginable power. The force of the water was so immense that it carved a massive canyon into the sea floor as it rushed in. This submarine canyon is still there today, a 320-kilometer-long scar that serves as a permanent monument to the violence of the Red Sea's rebirth. The water poured into the basin, drowning the vast salt flats in what must have been a torrent of churning, briny water. The entire process of refilling this 2,000-kilometer-long basin is estimated to have taken less than 100,000 years, which is the blink of an eye in geological time. This deluge re-established a permanent connection to the Indian Ocean through the newly carved choke point we now call the Bab el-Mandeb Strait, and it set the stage for life to return. This event was entirely separate from the more famous Zanclean flood, which happened almost a million years later when the Atlantic Ocean burst through the Strait of Gibraltar to refill the dried-up Mediterranean. The Red Sea's rebirth came from the south, a furious torrent from the Indian Ocean creating a new sea from the ruins of the old one. The flood that brought the Red Sea back from the dead didn't just refill an empty basin. It opened a gateway for life. Marine organisms from the vast Indian Ocean began to migrate into the brand new sea. Over millions of years, they evolved into the unique and vibrant ecosystem we see today. The Red Sea is now world-renowned for its stunning biodiversity, especially its coral reefs. These reefs host over 1,000 species of invertebrates and 200 different types of hard and soft coral. What's truly special about these corals is their incredible resilience. They thrive in water that is much hotter and saltier than what most corals can tolerate. This has made them a huge focus for scientists who hope they might hold the secrets to helping other reefs around the world survive climate change. This toughness might be a direct result of the sea's violent past. The repeated isolation and reconnection of the sea during past ice ages, when sea levels dropped, would have created intense evolutionary pressure, favoring only the hardiest organisms. For instance, during the last ice age, a big drop in sea level made the northern half of the sea so salty that it seems to have killed off most of the corals there. The corals we see in that region today are probably recent arrivals, having migrated in only within the last 10,000 years. The sea is also home to a huge number of endemic species, meaning they are found nowhere else on Earth. Again, This is likely a consequence of its history of isolation. But this unique world is fragile. The same geological forces that created it make it an unstable environment. And because it's semi-enclosed, it's very vulnerable to pollution from shipping and coastal development. And of course, the global threat of climate change looms large, causing coral bleaching events that are already damaging reefs in the southern part of the sea. This dramatic geology hasn't just shaped an ecosystem, it's profoundly influenced human history. The Red Sea's long, narrow shape made it a natural superhighway for trade between East and West for thousands of years. Ancient Egyptians, Romans, Arabs, and Europeans all used this waterway to transport spices, silk, and other precious goods. Its choke points, the Bab el-Mandeb Strait in the south and the Gulf of Suez in the north, have always been immensely strategic. But of course, the most famous story connected to the Red Sea is the biblical account of Moses parting the waters. While this remains a cornerstone of faith for millions, scientists have wondered if a natural event could have inspired the story. It's important to note that the original Hebrew text refers to a sea of reeds, which may have been a shallow lake or lagoon in the Nile Delta, and was possibly mistranslated as Red Sea. One plausible theory is a phenomenon called a wind set-down. If a strong, sustained wind of over 100 kilometers per hour blew for many hours, it could literally push the water of a shallow basin back, exposing the muddy bottom for a period of time. Computer models show that under the right conditions, this is physically possible. A land bridge could have appeared, and when the wind died down, the water would have rushed back in. This doesn't take away from the story's cultural power, but it shows how the unique geography of the region, itself a product of these immense geological forces, can create extraordinary events that become etched into human history. And in the modern era, we've even reshaped this geology ourselves, with the construction of the Suez Canal in 1869, creating an artificial link to the Mediterranean and revolutionizing global trade forever. So what does the future hold for the Red Sea? Its story is far from over. The rifting continues. The African and Arabian plates are still pulling apart, and the Red Sea is getting wider every single year. Its ultimate destiny, if things continue as they are, is to grow from a narrow sea into a full-blown ocean, a red ocean that could one day rival the Atlantic. This will take millions of years, but it will be punctuated by intense geological drama. The volcanic rift in its center will keep erupting, building new islands and triggering earthquakes. We saw a preview of this in 2007, when a volcano that had been dormant for over a century erupted in the middle of the sea. Could it vanish again? It's possible. Its existence depends on the Bab el-Mandeb Strait staying open. If future tectonic shifts were to close that gateway, the sea would once again be isolated and, given the climate, would inevitably dry up into a salt desert. More likely, however, are future catastrophic returns of a different kind. As the sea widens, the potential for massive underwater volcanic eruptions grows, which could trigger devastating tsunamis along its densely populated coastlines. The story of the Red Sea, of its vanishing act and its furious return, is more than just a fascinating piece of Earth's history. It's a profound lesson in how temporary our world is. The maps we draw are just a single frame in a very, very long movie. The landscapes we think of as permanent are constantly in flux. The Red Sea is a living laboratory where we can witness the birth of an ocean and be reminded that our planet is an incredibly dynamic, powerful, and sometimes violent place, always in the process of creating, destroying, and regenerating itself.